This is topic 9.1 and 9.2 for AP Environmental Science about stratospheric ozone depletion and how to fix the problem. Follow along with your learning targets, which are up here at the top of the slides. Make sure that you reference your study guides. Okay, so remember from Unit 7 that we talked about ozone pollution as far as air pollution. So we can have this little graphic here. This is down in the troposphere. So O3, the molecule O3, which is ozone, is not good for us in the troposphere. It causes lung damage, asthma, it causes harm to plants as well. It's the main component of photochemical smog. But we want this molecule up here in the stratosphere because it protects us from the sun's UV rays. So ozone naturally forms up in the stratosphere, so there's a natural way that it forms, so we'll learn those equations on the next slide. So it forms and breaks down and forms and breaks down, and UV rays break up oxygen gas up in the stratosphere. Now, if you notice on this picture, we're not in the stratosphere. So we have our cities and even our airplanes mostly fly in the troposphere. So there's very few things. You have your gases up here getting into the stratosphere. But as humans, we're not interacting up there, but it does protect us from UV rays. Okay, so the oxygen molecule, O2, is broken up by UV rays, and some of that rebinds with free oxygens to form ozone. And let's go ahead and take a look at the next slide. So here is our equations. So oxygen gas plus UV light breaks up our oxygen. Some of that recombines and gives us ozone, O3. And then it breaks apart again. So it has this cycle over and over again, breaking apart, forming ozone, ozone breaking apart, etc. So it's in a cycle. And so ozone is good for us. It blocks harmful UV rays, certain types, to varying levels of success. So we have UVs A, B, and C. And when you're getting sunscreen, try to find protection that covers more than just one type of UV. All three types of UV cause skin cancer, cataracts on eyes, which is like a filmy, kind of a hard filmy substance that a lot of older people have to get cataract removal surgery to get rid of them. And it can cause crop damage. So on the AP test, sometimes they ask about human health problems. So the first two would be that. And then they can also ask about environmental problems, and you'd have crop damage or plant damage. And here's another diagram of how the ozone layer can help block, especially UVC, and it reduces UVB, and you still have to really protect yourself from UVA. All right, so why is there a problem with the ozone layer in the stratosphere? A lot of times people call it the ozone hole. The official name is stratospheric ozone depletion or thinning. It's not really a hole, it's a thinning of the layer. So it's caused by a chemical called chlorofluorocarbons, which we always just refer to as a CFC. CFCs were used in the past up until they were banned a couple of decades ago. They were used in cooling, so anything that needs to be cold, like refrigerators, air conditioners, some propellants like spray paint cans, etc. And they were considered super safe because they're non-toxic, non-flammable. But we found out that the chlorine in CFCs, because it's chlorofluorocarbons, so there's chlorine in there, the chlorine molecule, when it gets up to the stratosphere, breaks apart the ozone layer. And this is kind of interesting. A single chlorine atom can break down 100,000 ozone molecules up in the stratosphere. So it was in the 80s that a couple researchers figured out there's a problem, and you can see here that at certain latitudes we have different percentages of ozone. So right here, this is the increase in UV radiation at different latitudes. So from the equator is at 0 latitude to we have 90 north and south. And there's increases in UV, especially as you get toward the poles, the North Pole and the South Pole, and especially Antarctic. So when you have a negative number here, that's a negative latitude, so that would be south. And so Antarctica has more ozone thinning, but the Arctic has some too. So the more that we manufacture CFCs, the concentration of ozone began to drop, which allows more UV harmful rays to reach the surface and ups our levels of skin cancer and other problems. Okay, so why Antarctic? So let's actually go to the second bullet point first. It happens mostly in Antarctica because there's ice crystals in the atmosphere which react with the chlorine to make the process worse. And so you can see that in this diagram. You can pause the video and take a look at the diagram if you want to understand the chemistry of it. What you need to know for my test and the AP test is that there's more ice crystals in the atmosphere which drive the equation forward to break apart ozone. And then why in the Antarctic spring? So really these bullet points should be switched around. So Antarctic spring is at the end of the Antarctic winter. Now remember, the southern hemisphere has opposite seasons from us. So this is actually September. So for us, it would be fall, but for them, it's their spring. So it's the end of their winter, and you have all this time of ice crystals in the winter to break apart ozone. And so most of the depletion occurs in the winter months, and it builds up, builds up, builds up. And so the beginning of the spring, you're going to have the highest levels of ozone depletion. So the lowest level of ozone, the highest level of depletion. Okay, so once we figured this out, we came together really as a global body and said, hey, we're not going to produce CFCs anymore because this is a problem worldwide globally. So they met in Montreal, and it became an international treaty to ban CFCs, to reduce its production by 50% by the year 2000. It has totally worked. So it took 25 years for the CFCs that were emitted before the ban to get up to the stratosphere to do its depletion. And once that was finished, it's now getting better. So it's a success story. But there's a drawback. So what we replace CFCs with is HCFCs, and they're a potent greenhouse gas. But we didn't know this at the time of the Montreal Protocol. We weren't really hip to all of the greenhouse gas problems at that time. It came later. Okay, so here's our global declines of CFCs in both hemispheres. So again, this is a success story. It's considered the biggest environmental success story on our planet. All right, that's it for 9.1 and 9.2.